A parabola is the graph of a quadratic equation. And much like a line has different forms, such as standard form and slope-intercept form, a parabola also has different forms. The first form we're going to look at is vertex form. Vertex form, in general, looks like this. Y equals a number, which is a little bit like the slope, times quantity x minus h squared plus k. If the vertex form looks familiar, it's because we have already studied absolute value equations. If you remember absolute value equations, when we graphed them, made a V with a vertex at -1, -8. The vertex form of a parabola looks a lot like the equation of a absolute value, except for the absolute value will be replaced with parentheses and a squared. So we do have a quadratic because we have x squared. We just have it written in vertex form. Now, in order to graph a parabola, we first want to find the vertex. In this case, the vertex is going to be hk. In our example, the vertex is going to be the x value that makes this 0. If you remember, to find this vertex, it wasn't 1, it was the x value that made this whole thing 0. We're looking for the x value that makes this 0. So we want x to be -1, followed by k, in this case, -8. Once we know the vertex of our parabola, we want to create a table centered at that vertex. So I'm going to make the middle number -8, and then I'm going to go 3 numbers bigger than -1 and 3 numbers smaller than -1. And I'm going to plug these x values into this equation to figure out my y value. Input, output. When x is -4, y is 10. Now I'm going to hit second enter, and when I hit second enter, the previous entry pops up, and I can scroll over and change my -4 to a -3. Do the same thing with -2. -1, we already know the answer for, so let's go to 0. And when I go to 0, I have to delete this negative sign. After my table is filled out, plot these points. After the points are plotted, connect the points to create a parabola, a U-shaped graph. If you look at the table, the numbers on the left and the right should be the same. Because our parabola is symmetric, there is going to be a line of symmetry. The line of symmetry sometimes is called the axis of symmetry. The line of symmetry is a vertical line, so the equation of that vertical line is going to be x equals a number. In this case, it's going to be x equals -1. The standard form of a parabola looks like this. Y equals a number times x squared plus a number times x plus a constant. We have a quadratic because the highest power of x is 2. An example would be y equals 2x squared minus 8x plus 6. Standard form is like taking the vertex form and foiling out this parentheses. In order to graph a parabola in standard form, we first need to find the vertex. Now, in order to find the vertex, we're going to borrow a page from the quadratic formula. We're going to take the first part of the quadratic formula, negative b over 2a. Negative b over 2a will be the x portion of our vertex. For our example, I'm going to find that x value of our vertex. X is going to equal a negative 8 divided by 2 times 2. So we have the opposite of negative 8, which is 8, divided by 4. And 8 divided by 4 is 2. Once we know our x portion, to figure out our y portion, we need to take this value and plug it in for x. We need to take this value and evaluate our function at this number. We need to take f of negative b over 2a. If you remember function notation, we're going to take our function and input this number. Once we do all that math, our output will be our y value. So I'm going to take this 2 and plug it in for x. So y is going to equal negative 2. So our vertex is going to be at 2, negative 2. Again, once I know the vertex, set up a table centered at that vertex. Go a couple numbers bigger and a couple numbers smaller. Plug those x values into the equation to figure out the y values. I can hit second enter and plug in negative 1 where the 2 was. Now, in order to get a negative sign in there, I'm going to have to insert. So I'm going to hit second, insert, a negative 1. Second, insert a negative 1. delete the negative, delete the negative, good. I got the same answer. I want that. It's a good double check. Plot these points. I can't plot these. These are too big for my graph, but that's all right. I still get a pretty good idea what my parabola will look like. My line of symmetry will be this vertical line, x equals 2. Intercept form, in general, looks like this. Y equals a number times a binomial times a binomial. An example would look like this. Y equals negative x plus 4, x minus 1. It's kind of like I take standard form and I factored it. Think of intercept form as being factored. I still have a quadratic because if I FOILed this back out, I would have x times x, which gives me my x squared. Now, in order to graph an intercept form, I first need to find my zeros. If you look, I can figure out what x value makes this binomial 0. And if x is negative 4 plus 4 is 0. And the opposite of 0 is 0. And when I plug negative 4 in here, I'm going to have negative 4 minus 1, which is negative 5. But this is going to be 0. And 0 times negative 5 is just 0. And the other 0 will be at 1. When x is 1, this is 0, which is going to cause everything else to be 0. So my output will be 0. In general, the zeros will be at P and Q. Now, in order to find the vertex, I'm going to plot these two zeros. If I plot these two zeros, the line of symmetry has to be in between these 2 points. My line of symmetry is going to be right here. And if you look at the line of symmetry always gives me my x value of my vertex. So in order to find halfway between these points, I'm going to find the average of these 2 numbers. I'm going to find the midpoint of these 2 numbers. So in order to find the x portion of my vertex, I'm going to take negative 4 and 1 and find their average. Negative 4 plus 1 is negative 3 divided by 2. So the x portion of my vertex is going to be negative 3/2, which is negative 1.5. In general, my vertex will be at, the x portion of my vertex will be at p plus q divided by 2. Now to figure out my y portion, I'm going to take this number and plug it in for x. So my vertex will be at negative 1.5, 6.25. In general, once I know the x portion of my vertex, to find the y portion, I take this value and plug it back into my function. I'm going to take my function and evaluate it at p plus q divided by 2. Once I know the vertex, set up a table centered at that vertex. Negative 1.5, 6.25. Now when I go bigger than negative 1.5, I'm going to go to the next integer bigger. The next integer bigger than negative 1.5 is negative 1. And the next integer smaller than negative 1.5 is negative 2. Now I can input these x values into my equation to figure out my y's. If I hit second enter, I can change my negative 1.5 to negative 4. And I get 0. Change the negative 4 to a negative 3. Change the negative 3 to a negative 2. Then to a negative 1. Then to a 0. And finally, change the 0 to a 1. Plot these points. Negative 4, 0, negative 3, 4, If you look, this parabola is going to open down. The clue that tells me that this parabola is going to open down is this negative sign right here. Whenever my a is negative, my parabola opens down. Whenever my a is greater than 1, my parabola opens narrower, it's steeper. Whenever my a is less than 1 but greater than 0, then I have a wide parabola. My line of symmetry will be at this vertical line when x equals -1.5.